It is the what significance you want to find the coefficients. So it is 10%, 5% and 1%. If 1% it is more accurate, and if 10% is less accurate. However, you see the value of coefficients are given accordingly. So the first step will be to find the skew of the data set. According to the value of skew, you find you select the according to the value of skew, you find the value of coefficients after you have chosen about the level of significance, because that will change the value of coefficients. Okay, and another thing is that if your skew is within this value 0.5 to 1 or 0 to 0.5 or minus 0.5 to 0 or minus 1 to 0.5, just interpolate. That means for 1.0 skew, this is the coefficient C1. For 0.6, what will be the coefficient? Simple unitary method. For 1 skew, the 1% level of significance coefficient is C1, value of C1 is 0.00023334 as is shown in the table. Now what will be the value of C1 for a skew of 0.7? Suppose your skew have come out to be 0.7. Just unitary method, nothing else. Okay, so that is clear. So this table is for the finding the value of the coefficient for detecting one outlier, single outlier, and the sample size is 10 to 15. Similarly, for sample size 16 to 150, these are the values of coefficients. Okay, so these are the values of coefficients. There also first find the skew, then if it is within 0.5 to 1 or 0 to 0.5, interpolate, that means use the unitary method and find the value of C4, C5, C6, C7. Because in case of 16 to this 150, you can see you require the value of not only 1, 2, 3, C1, C2, C3, but also C4, C5, C6, C7. That is why in this table the value of C is given from 4 to 7. I think it is clear. Similarly, these two tables are for single outlier detection.